Good afternoon, everyone. My name is Thibault Lestang. I'm a research software engineer at the University of Oxford in the Department of Computer Science. I'm a member of the research software engineering team there, and I'm also a junior research fellow at Kellogg College. So today I want to talk to you about GNU Emacs, and especially I want to show you how I think GNU Emacs can be a fantastic tool for research. And in particular, I'd like to give you a taste of Orgmode, which is a specific part of GNU Emacs that was initially developed by a researcher for researchers. And this specific subset of Emacs is making it very easy to maintain consistency and reproducibility throughout the research process. And that's usually something that's a real challenge, because scientific research is made of a wide variety of activities. You've got data collection, data processing, you've got making figures, plot tables, and writing papers, and it's truly difficult to keep track of everything, to make sure that data, code, figures, notes, papers are at all times connected in the right way. And when they are not, this is when you've got inconsistencies and errors that can, at best, cause a very frustrating morning, and at worst make your research impossible to reproduce by somebody else. So in order to avoid that, we want to work in a computational environment that makes keeping things consistent easy, almost like we don't have to think about it. So to be a little bit more specific, we want a very clear relationship between data, code, and analysis, your scientific conclusions. So when we look at data, we want to see what software generated that data. When we look at a figure, we want to see what generated the figure and which data this figure corresponds to. And when we change the data, or when we change the software, we really don't want to have to go and manually propagate that change throughout the whole research pipeline. We want it to be automatic, because when we do things manually, that's when inconsistencies just sneak in. Another very important point is that we want the software, we want the tools that we rely on to be usable by anyone, especially across operating systems and versions of them. And finally, we want our tools and formats to be usable, obviously, right now, but also in the future. So when you look around for workflows for reproducible science, you find typically something that looks like this. And here you can see that there's a clear pathway from, on the left side, the data, and on the right side, the actual end product, which in this case is an article, it's a PDF file. What's great about this particular workflow is that it's relying on plain text, and plain text is the most portable and future-proof format, and we'll talk a bit about that later in this talk. What is less great about this workflow is that it's quite complicated. You can see that there's a lot of different moving parts, and it's also specific to somebody who works with R and is using this markup language called R Markdown. So instead of relying on many different software, I want to show you that we can actually achieve a similar workflow with Emacs, and especially with Orgmode. And this workflow is not going to be restricted to any particular language. Using Emacs is going to allow us to make all the steps from all the steps of that workflow, from data to paper, all from within Emacs. So writing code, executing code, gathering the outputs of the code, making figures, writing the notes, writing the papers, exporting the text to a PDF, to HTML, all that from a single software. So one integrated and a consistent environment. And so now what I'm going to do is, I'm going to jump into Emacs, and I'm going to show you what it looks like. So here's a file open in Emacs in Orgmode. It's just a plain text file, but you can see that Emacs is displaying its content in a way that helps structuring the document. And this is done according to a very simple syntax. So for instance, stars for headings, you can use forward slashes for italics, you can write in bold, you can write lists, you can write links. So writing in Orgmode is actually very similar to writing in other lightweight markup languages, just like Markdown, ASCII-Doc, or restructured text. So this is all plain text. So if I just jump into a terminal, and you can see that if I use if I use cat, then I can just see that this is just plain text. And it turns out that Emacs just renders links when it or structures when it just it just passes the document to render it a little bit nicer. So this is to say that you can basically work on that document using any text editor. You could use Vim, you could use Atom, you could use VS Code, whatever you want, because it's just text. You can read it and you can modify it. Now, the benefit of working with org files in Emacs is that obviously you benefit from Orgmode, and Orgmode is giving you a lot of different functionalities to work with these files very effectively. Right, so you could move some headers around. You can fold things, so I can fold that, for instance. I can move to the previous header and fold it as well, etc., etc. So there's really a lot of functionalities. It's not necessary to know all of them. I personally just know a very small subset, I think, though it's enough so that I feel that I'm quite efficient working with text, which is what matters in the end. Once you're done editing your document, you can go from this text file to a much richer format. So, for instance, PDF, HTML, ODT, and that's very simple. You can just hit Control-C-E, and you get a menu asking you what kind of format you want to generate. So, for instance, I could do an HTML file, and here we go. That's our document in HTML. It's bare bones HTML, there's no CSS, but you could very well make it look a little bit prettier by adding some CSS. If you're working with people that are used to Microsoft Word or LibreOffice, you can export some ODT file as well. Here we go. So that's very convenient for collaborating across software. You could also generate PDF files using LaTeX. You could translate that org file into a Markdown file, into a restructured text file, into basically any other type of markup languages. And there are a lot of other third-party exporters and people that have been writing and contributing to the community. So that's for kind of the workflow of starting and writing your content in text file and then exporting it to a richer format. But it's also possible to work with code inside Orgmode documents, and that's something that I'd like to focus about. So for that, I'm going to open another document. So that's just another org file, and this org file has a first section that contains some code in C++. So that's why it's called a code block. It's some code snippet that's enclosed in these tags begin src and src. And you can see that in between these tags I've got nice syntax highlighting. I could fold it as well if I want to, if the code is long and I don't want to see it. What's very convenient is that, well, I could write code in here, I could continue and write some code in here, but I would not benefit from the indentation, auto-completion, etc., etc. So what Orgmode allows you to do is to, from a source block, quickly open a separate buffer in which you can work on your code. And here you can see that I'm in the right mode, I'm in C++ mode, so I'm going to get all what I want, so completion, debugging, to work with C++. And once I'm done, I can quickly go back to the actual org file. Good. Another thing I can do that's very important is that I can actually execute this code block right from Emacs. So if I hit Control-CC, then Emacs is going to compile the code snippet and get the result and display the result in the org file. So here you can see the result is a 2D array, and the first column is the time, and the second column is the value of the observable of interest. And I realize now that I didn't even tell you what this code does. What this little code snippet does is that it simulates this equation of motion here that you can't read because LaTeX is really hard to read, but it's basically a simple random, a simple stochastic equation. And what we are interested in is the dynamics of this variable x here. And this is the second column. So Orgmode, very easy to write some code and very easy to execute the code and get a result right into the same buffer. Okay, so this is a code block in C++. We've got C++ here, and we've got a lot of other things all there. And these are basically options, because in Orgmode, code blocks are really flexible, and the way you can access this flexibility is by using what is called header arguments, and these are header arguments. Some are specific to languages, so for instance here you've got includes, which is specific to C and C++, because this is a list of the actual headers that you want to use when you compile your C or C++ snippet. Then you've got this cache header here, which is telling Orgmode to cache the results of, cache the output of the code block, and to do it unless the code was modified, I think. And then you've got this noweb argument that is basically allowing us to use this noweb syntax here. And lastly, this code block has a name. It's optional, but we can then, this is what we can use to refer to this block from other blocks. And this is something that we're going to use just now. Okay, so that's for the simulation code. We're done with it. I can fold it. Now there's another section that's basically visualizing the time series. So for instance, once you computed the time series, once you solved that dynamical equations, you could say, well, I want to see what the data looks like. So for instance, we could use Python. So here's another code block using Python, and what this code block does is something that I think is a key feature of Orgmode, is that you can actually use the output of one code block as the input of another one. So for instance here, we refer to the C++ code block, which is named initial data, and we say that in the Python code block, we want a variable called time series that will contain the output of the C++ code block. And you can see that here we've got a variable which is a plain Python list that we then convert into a NumPy array, and then we can plot it. So what this code does is that it's going to save a figure, and it's going to do it in a separate directory that is specified here, using this dir header argument. So we just say that, oh, this code block is going to be executed in the figure directory, and we want the results to be a link to a file. So it's going to be a link to the actual image that is generated. So I can go ahead and hit Control-CC and then execute that code block. Here we go, and now I've got a link towards the actual figure that I can open as well. I could also say that I want to see figures right in a document, and here we go. So that's the solution of the random equation that we just solved with the C++ code, and we plotted it using Python. Now we could say, well, we want to do a bit of statistics, so we want to, for instance, compute the value of the average of that time series, and for instance, we could want to discuss the value. And very often when you write notes or papers, you've got some information that's very dynamic. So what I mean by that is that, for instance, the value of the mean here is really dependent on the parameters, for instance, or the time step that you would use. If you change the parameters, if you change the time step of the simulation, then when the value of the average, for instance, here would change. So you don't want to have to manually go and look for every occurrences of the mean and manually replace it, inputting the right number. What we can do with Orgmode is that we can basically do an inline call to a code block in the text, so that we don't have to manually input or basically hard code the value. So the way it works is that it's just the same as before. We just create a new named code block. And so, for instance, here the name is mean, and it's got a header argument that defines a variable x that defers to 0. And we then say, well, this code block is going to read x and going to return the average of the second column. And now in the text, we can write sentence like, well, in here we discuss the fact that the empirical average over the time series is, and instead of hard coding the data, basically instead of copy pasting the data here, we just make a call to this code block. So call mean, and then we give it the input, which is the output of the C++ code. And so here we can ensure the fact that our document remains consistent even if we make changes to the data or the code that generates the data. Right, so this is just a very, very quick overview. There's a lot more to Orgmode, and there's a lot more to working with source code in Orgmode. I've got the, well, it's a shame I don't have it here, but I've got the manual for Orgmode, the actual book, and it's really thick. So there's certainly a lot of flexibility in there. But the important thing to keep in mind is that it's actually really easy to start with Orgmode. You don't have to learn everything at once. You can just literally start with a simple document, a few headers, a little bit of markup to take notes, for instance, and build upon that step by step. So if Emacs is so useful, why isn't it more popular among researchers? I think Orgmode and Emacs, mostly Emacs, has a reputation of being reserved to, a reputation of being old and being reserved to a population of computing experts. Well, Emacs has a very long history. It is old software, but it's certainly not obsolete. We just saw that it actually comes with very modern ideas and modern functionalities. So Emacs has been maintained and extended over more than 35 years, which is a very, very long duration in terms of software lifetime. And it's been mostly maintained by its own community of users, very much independently from any commercial purpose. And I think these 2 points set Emacs aside from the majority of other editors, and also from other software that we use day by day nowadays. And I think this explains why Emacs feels and look different from these. An important aspect of Emacs is that it really encourages users to invest a bit of time in it. It encourages you to invest in your tool in order to become more comfortable in it and really to make it your own. And I think that philosophy does not match really well with the kind of publish or perish environment that actually many researchers evolve in. And well, that's a shame, because I think the return on investment for learning a bit of Emacs can be really massive. And this investment doesn't have to cost really much. I'm talking just setting 30 minutes aside and going through the tutorial. That can already go a really long way. Because what you gain from learning a bit of Emacs is a work environment that is particularly well suited for research, and especially reproducible research. The first reason why I think Emacs is suited for reproducible research is because if you're working with Orgmode and Emacs, well, everything is just plain text. So that means you can modify everywhere, and anybody can. It's also great for version control if you want to keep track of changes using Git or Mercurial. As I showed in the demo, it's great to work with. You can use a text editor. It doesn't have to be Emacs. You can use it could be another text editor. But working with plain text allows for a very, very efficient work, basically, in manipulation. So because I kind of like this idea of you work with plain text, you focus on the content and the structure of it, and then as a separate step you export to a richer format, and then you can think about distributing your content and focusing on the look of it. So we just talked about the format, and now if we think about the software itself, well, Orgmode comes within GNU Emacs, and GNU Emacs is one of the most ported software out there. You can literally find it anywhere. If you're working on Windows, you'll get GNU Emacs there. If you're working on Mac, you get GNU Emacs there. Linux, of course, you get Emacs there. Even if you're working on a remote server and you don't have a graphical interface, you can still use Emacs. And the last point I want to make is that both Emacs and Orgmode are free software, and I mean free as in freedom. That means that there's actually no restriction whatsoever to use Orgmode or use Emacs, and in particular, it doesn't cost any money to use, and that's really good, I think, for smaller university or smaller organizations that can really benefit from saving on software licenses. It also means that anyone can read and modify the source code of Emacs and Orgmode. You might think that's not really relevant to you because, if you want to tinker with the Emacs source code, that demands a lot of time and very specific skills. But the important point here is that people can modify the code, people can fix bugs, extend the software, and people do. Maybe not you, but other people will do. And actually, the whole development of the Emacs ecosystem is very much a community effort. There's no company behind Emacs. There's no company behind Orgmode. It's all by users, for users. And it's not driven by any private interest. And I want to conclude this talk by saying that I think this very specific aspect of Emacs makes it particularly suited for academic research. So that's it for me. I hope you found the talk interesting. I hope that it gave you food for thoughts, and I'll be now really happy to hear your comments, hear your questions, and try and do my best to answer them.
Hi Thibault, thank you very much.
Okay.
What a fantastic talk.
Thank you.
Right, as an Emacs and Orgmode user myself, I'm very pleased you're able to talk about that. It's I think it's important. Okay, to start, we've got a question in the chat from Agatha. If you modify the code in the blocks, how would you keep track of what has changed and of previous results?
Yeah, so the problem is quite similar to what you would experience with a Jupyter notebook, right? Because you can execute you would execute the code block, but then the changes are propagated to the subsequent steps, but you also want it to be consistent with the previous steps. The way it works, like the typical workflow when you're working with Orgmode, is that you would maybe make changes, but then when you export your document to HTML or to LaTeX or to whatever format you want, everything's going to be executed in line. So everything's going to trickle down. So you would re-execute everything. So of course, when you have code that's really computationally expensive, you would not do that, but usually that's what you do. You just re-execute everything.
Okay. The next question is perhaps a specific one, but maybe interesting. We have someone who's running a local Emacs on a remote server, and they want to be able to generate files on the remote server. Can you display those files in the Emacs buffer?
Yeah, I mean, if you're using Emacs, well, say, I don't know, you're using Emacs through SSH, and then you don't have a graphical interface, so you're using Emacs in the terminal. Then, depending on most terminal emulators, you would probably not be able to display inline images. Now, something that I'm not using myself, but I should definitely start using it, is called Tramp. I'll put a link to it in the chat. So it's the way of, from Emacs, running on your machine, editing files through SSH. And so there you can have a graphical interface. You can use Emacs using your Windows system, but the file that you're editing is on the remote server, and then you can display inline images, and then the files themselves live on the remote server. So it's called Tramp, T-R-A-M-P. It's not something that's obscure; it's widely used.
Cool. A question which is a follow-up from mine, so I'll ask mine first. Would you say that Orgmode is better Jupyter notebooks, or better than Jupyter notebooks for most use cases?
Yeah, that's the tricky one.
I'm asking you to perhaps go out on a limb here a bit.
Yeah, no, that's the interesting one. I mean, the other as well are interesting, but this is particularly a tricky point. So I don't want people to think that I'm saying you should drop Jupyter and switch to Emacs. I've used Jupyter in the past, but from my use, which has been both research, generating data, analyzing data, but also now that I'm in RSE working on software, I've been finding that actually Orgmode gives me more functionality and I'm more confident using it for many reasons. The first reason is that it's within Emacs and I'm used to it. That's a very personal reason. And then, as you can see, Jupyter is to some extent limited to Python. I mean, you could use it without, but you can't really mix programming languages. That's the first thing. But for me, the main reason why I would use Orgmode is that it's plain text. So I know that now you can version Jupyter notebooks, but it's always not so straightforward to use Git or Mercurial to version control these files. When you have plain text, you don't even have to think about it. It's just a text file. So that would be my main reason for it. Now, obviously, the downsides of Emacs is that you have to be a little bit used to Emacs, and there's a question about that. And then Jupyter Notebook, it's in a web browser. You can graphical interface, so it's much easier to get started, obviously. But if you know a little bit of Emacs, then I would really encourage people to have a look at Orgmode and then find it if it's good for them.
Okay, the follow-up question is whether you see a need for maybe certain groups of people to shift from Jupyter to something like Orgmode.
Again, it's depending on what you want to do. I think Jupyter is great for many people. I mean, there's a reason why it's widely used, right? But I think the fact that you can actually the fact that it's plain text, the fact that you can combine multiple languages together, the fact that you can export the document, so you can, I think, you would be able to, from a Jupyter notebook, export it to a presentation or website, but it's it's so easy from Emacs. Sorry, so no, I don't think there's a need. I wouldn't go that way. I just wanted to, the point of this talk is to illustrate Emacs and the ideas that it brings that do not exist in other systems.
Just out of curiosity, did you use Emacs and Orgmode to generate your slides?
Yeah. Thank you for asking. I'm pleased I can make that point. So yeah, of course, these slides are Emacs, and I've put a link to there's a Git repo. I've put a link in the chat, and you can find the org file that corresponds to these slides. And then you write these slides, star header 1, star header 2, the content, and then you just hit the keystroke, and then it makes you a nice HTML presentation. Obviously, I had to add a bit of CSS, but there are people who very kindly spend time developing nice theme for your Emacs presentation. So if you don't want to spend time writing HTML and CSS, fair enough, but you can just get a theme and apply it.
I think there's a reveal.js export option which that looks like.
Yeah, this is what I used.
And maybe
there are others.
Final question is how easy is Emacs to pick up for maybe junior programmers as opposed to a full-featured IDE like PyCharm?
Yeah, it's another very important point, and I think it links to Emacs Orgmode versus Jupyter. So the main downside of Emacs and Orgmode is that my colleagues don't use it, right? And then there's you can't really you find yourself a little bit alone sometimes, and you have to collaborate. It's not that easy. And so I think the reason that it's not as widely used as Jupyter is because obviously Emacs has a bit of a learning curve, right? So, but it's not as bad as people think. That's my opinion. And especially with Orgmode, it's very easy to start with Orgmode. And so you could, as I said in the talk, you could just start using it as you would write Markdown really to take notes. If you're using Markdown already, you could use Emacs right away. Emacs easy to install. You might have to spend maybe like half an hour just figuring out the few shortcuts that you need, but then you can change them if you want, and then you're good to go with Orgmode. And then there's now a very recent and up-to-date getting started guide in Orgmode, and so you can just follow that and get you started and have a taste, and then if you don't want to use it, just don't use it, but then you can have a taste very quickly. And I think it's not that hard to use. It's hard to master if you want, but it's not that hard to get started with. And my last point is that Emacs is widely configurable. You can spend a lifetime configuring Emacs configuration. But for people who want to get started quite quickly with a kind of working software, as you would expect from VS Code or to have all the functionalities that you would expect from an IDE or text editor, there are pre-configured versions. So examples are Spacemacs, Doom Emacs is widely used, and Emacs Prelude. So it's all like kind of Emacs distributions almost, that gives you everything you need to get started right away. Orgmode is installed, various plugins. The appearance is better than the vanilla one, so all this kind of stuff. So if you want to get started, I encourage you to have a look at that and go through the Getting Started guide.
Great. Thank you very much.